Let's start recording. Welcome to the last day of week 5, which is either day 2 or 3, depending on if you count Labor Day. So we just finished the last class, which started at 1 because of the 9/11 remembrance. It was a pretty good event. The guy who was talking was actually the father of a former student of mine, Standriff, and he's a radio talk show guy, and talked about his experience. He was playing golf with a bunch of NFL Hall of Famers and 9/11 hit, and he ran a radio talk show for 24 hours. Like pretty intense stuff. And talked to him afterwards. He was very nice, and he talked about how his student, enjoyed my class and stuff like that. It was really good. I talked to him for about 10 minutes afterwards. And so 20th anniversary of 9/11 is tomorrow. Personally, I slept through it. My alarm didn't go off because I had a radio alarm that would play music, but no music came on. It was just people talking, and so I didn't wake up. I'm like, oh, this is a commercial or something, But it was actually, they'd taken all the music off the air, and they're having people broadcasting live about 9/11. And so I'm just like, what the hell are these people talking about? It's like this commercial's been going on forever, so I just click it off, and then slept till like 11 or something. And then my roommate started knocking on my door, and he's like, dude, you got to get up. There's something happening. And so I, hear about this, and I go over to my parents' house. It's already like 2 o'clock in the afternoon, East Coast time. So I slept through the Twin Towers being run into, and the collapse, and the Pentagon, and United Flight 93. Slept through all that. Beautiful day across the country, it sounds like. Very beautiful. And I go over to my parents' house, and my sister was in Italy at the time, and she was supposed to be on a flight from New York to Los Angeles, and that was one of the flights that was hijacked. And I'm just like, wait, was she on that flight? And they're like, we don't know. And I'm just like, oh damn, what day was she supposed to fly? They're like, tomorrow. And I was like, oh good. But wait, is it tomorrow in Europe? Wait, how does the time zones work? So I'm sitting there like trying to I start panicking, and I'm like trying to figure out the time zones. Like, are they a day ahead of us or a day behind us? Like, how does that work, And trying to figure out if my sister was alive or dead, So we couldn't get through to her. And it turned out it was the next day, in fact. If it was Japan's tomorrow, by the way, right? So it is 4 o'clock in the morning tomorrow in Japan right? So that would have been bad. But my sister got stuck in Italy for a couple weeks and had to stay at an Italian villa, which I guess worked out okay for her. One of the women I knew that worked at the local Jamba Juice was on one of those flights and died. She was on one of the hijacked planes, and they flew into the Twin Towers and killed her. Always pisses me off when I see these conspiracy theory people saying like all the people were let off the plane and dummies were put on and flown into the plane. I'm like, no, burn in hell, dude. She was a nice girl, and got killed 20 years ago tomorrow. So it's kind of weird that every year that I teach, the students that remember, it was like, I was 6 years old when 9/11 occurred. I was 5 years old. I was 3 years old. I was 2, and I used to guest teach here before I started teaching professionally. They're like, I was 11, I was 10. It's weird. It's like this reverse aging thing when people talk about 9/11. Like every year they were a year earlier, except for the older students, they're taking classes. And I think it's important not to forget it. As much as like we talk about how horrible America is and how divisive our politics have become, and some of that was the result of 9/11, to be sure. Like the war in Afghanistan and Iraq came about due to 9/11. Really, like I don't think we would have invaded either of those countries if it wasn't for those terrorist attacks 20 years ago. But as much as people kind of crap on America and say how horrible it is and how critical they are of like everything American, 9/11 really did show how Americans could pull together and the strength and spirit of our country. And I mean that dead seriously. Like, I can be somewhat sarcastic at times, and I usually try to put a light spin on things. But in all seriousness, like, the outpouring of support from like all corners of not even America, like the globe. Like Standriff was saying that there was a town of 7,000 people in Newfoundland that all these planes were in the air got rerouted to them, and so the town doubled in size, and they had these 7,000 unexpected guests in their town for 2 weeks because no planes were flying, and they just opened up their doors and took care of the people. And apparently there's a Disney musical about it premiering tonight or something, I don't know, on Disney Plus. And one of his friends is from there, and Gustine or something, I don't remember the name of it, in Newfoundland. But yeah, like the American spirit there is something to it, and it's not all just terrible, and it's not all just like whatever these critical people always say. Like there is something resilient and helpful, to the American character, where we really do go out of our way to try and take care of each other, when the chips are down, Americans are very, very good at giving. Like, we're one of the most charitable countries in the world, and a lot of that just kind of gets swept up into this ultra critical thing, because in politics it's all about kind of bad mouthing the other side, and so all the good kind of gets lost, I think, in that. Okay, so enough about 9/11. I'm sure you'll hear more about it, but that was my story. Was it? I slept through it, and thought for a while my sister was dead. Okay, so today we're going to be talking about call by reference, and call by reference is one of these really important topics in CSI 40, especially, that it can be hard for students to learn, or it could be easy for students to learn. And the way that I like to teach it, I think, makes it a little easier to learn. So I'll start off with a simple example. If I make a simple algebraic function like this that just takes in an algebra, it's f of x, C++ is that, and let's see, an algebra, I'm going to do f of x is equal to 4 times x minus 10 or something like that. I could write it like this. Okay. So I've made a function here that is basically going to take in a value, multiply by 4, subtract 10 from that, return the result. So if apples is equal to 4, what is f of apples? Can you guys do that math in your head? Six factorial. This is from the 9/11 event. It is 6, yeah. Good. And so, we can verify this by running it. 6. All right, so now let's say we see out apples before and after the function. What is it going to print here? You know what it's going to print here, right? It's going to print, was it 6? What is this going to print? 4. And now, what is it going to print here? Does passing apples to f change apples? 4, not factorial. 464? Yeah, you guys all got it. So, yeah, if you pass apples to f, it doesn't change apples. It would be very odd if you pass the value to a function and then that thing gets changed, right? It would be very strange. So yeah, you got this. It's going to do 464, and if we run this, 464, good. Everything's working the way we expect. Now, what is a variable? A variable is, it's a name, apples, It's a type, int. It's a value. A variable is a name, apples. A type, int. A value, 4. And a memory address reference. Okay, that's the location in RAM where that variable is. So you're going to read and write to a spot in RAM. And the compiler handles it for you. Normally we don't care, but if you're curious, you can print this out. Print out the memory address, this is also called a reference, of apples. So you guys want to see where in RAM apples is? It's going to look like garbage, but you want to see? Curious? Yeah, all right. It's going to look like garbage, but there you go. So that is the spot in RAM where apples is. Okay. It's near the very top of RAM. The very top of RAM is 7FFFFFFFFFF. Press F to pay respects. So it's a little bit down below the top part of RAM, but it's really near the top. And there's a reason for that. And then we can also print out the value of X. So we can see out the value of X, and I'll just say the address of X is, and I'll come in here and say the address of apples is, and you can see that apples and X have a different memory address, right? These variables live in some different spot in RAM, like somewhere within the depths of, well, it's not my computer, and the computer in the cloud somewhere. There's somewhere in a data center in Fremont, there's this server, our class server. And somewhere inside of that rack-mounted beast of a machine is a chunk of RAM. And if you got an electron microscope out and stared deep inside that block of RAM, you might be able to just find apples, right? You might be able to see there, oh yeah, that one's set to 4. And then this one, which is nearby, but not the same address. If you guys look at this, most of it is the same. You see that? Most of the memory address is the same, right? It's just the last 2 digits are off. So it's pretty close by. It's like 30, let's see, 20, 10, 11, 12, so 8, 28, it's 28 bytes away. So X is 28 bytes south. It's probably on the same RAM chip, just like a little bit, a little bit to the right, and you can see in there, okay, that's physically where the variable X is, and right here, and you're looking at this at 10 million times magnification, okay, that little block of silicon right there holds apples, and that block holds X. It's a different spot in RAM, okay? You guys see that? So that's why when we modify X, we don't modify apples. Does that make sense? So like when we do this, we're changing X, right? X is being multiplied by 4, X is being subtracted by 10, see out, X is now X is now 6, right? But that doesn't change apples. Apples is still 4. And do you guys see why? Because when you're reading and writing to X, you're reading and writing to that memory address, and apples is not there. Apples is at a different memory address. Does that make sense? So you're reading and writing to this guy who's X, and apples is left untouched. Is that kind of straightforward? You're changing, like X was initialized to 4 from apples, but it's just a different variable. You're changing a different variable. You can see right there, it's a different spot in RAM. Okay. So, yeah. So when you do this is called call by value. X is being passed call by value, which means X is a clone of apples. Okay. It's a different value. It's a different variable. X is a different variable. it is just initialized to 4 because apples is 4. That makes sense? That's the way we kind of think it should work, right? You pass in apples, then there's a variable here called x, and it's initialized to 4 because apples is 4. And then when we're doing all this work on it, like, it's not changing apples. That would be really weird, right? Okay. So now, let me modify this a little bit to show a little bit more. The original value of apples is and the new value of apples is adding a little bit of descriptive text there. It's not going to affect anything. So the original value of apples is 4. X changes to be 6. It returns 6. Yeah, I should probably take those out. Huh? So f of apples is 6, and the new values of apples is still 4. Right. So we pass apples in, creates a variable called x, totally different, modifies it, good to go. Now, watch what happens if we change just one thing. So what does that ampersand mean? Well, this thing might give you a clue. Okay, in C++, the ampersand is the memory address of operator, sometimes called the reference operator. So it gives you the memory address of a variable. And so in this case, what's being passed in is not a copy. It's actually passing in apples. Okay, let me show you what this looks like if I run it. I run this. Do you see this here? The address of apples is that. The address of x, it's the same memory address. Look at that. You guys see that? So x is now the same memory address as apples. You see that? They're not two different variables now. If you pass in something with that little reference thing in there, what happens is that it doesn't make a duplicate. It doesn't make a clone. You're actually passing apples in. Okay? You guys see that? The memory address of apples is 7ff, duf, da, da, da. The memory address of x is the exact same memory address. When you read and write to x, you're reading and writing to apples because it's the same spot in RAM. If you increase x by 1, back in main, apples went up by 1 also. Why? Because it's the same spot in RAM. There's a spot in RAM that holds the value of apples, and when you're reading and writing to x, you're reading and writing to apples because it's the same memory address. You guys see that? And if we run it again, by the way, you'll get a different memory address. You see that? It's not always the same memory address. But these guys, apples and x, are always the same, even though it changes from run to run. Okay. So the original values of apples is 4. After you call f of x, it's now 6. So what happened here was, whereas before this was 4, 6, 4, by putting that one little character in there, it is now something called call by reference. Okay. So x is now passed call by reference, which means it does not make a copy. X is actually really just apples back in main. Changing x will change apples. So down here, this is now 6. Okay? So if you pass in apples to it by reference, then like we saw here, that's actually the memory address of apples. And so when you multiply it by 4 and subtract 10 from it, you're modifying this person. Okay, I wouldn't recommend writing code this way, by the way. I wouldn't recommend writing code this way. This makes no sense to me whatsoever. Like if I've got some sort of algebraic function and I pass apples to it, I would be very confused if apples changed. Okay. So ampersand is directly referring the memory address to x. Yeah. So what this means is you're not passing, what you're actually passing is the memory address of apples. And so x has the memory address of apples. And so when you read and write to x, the memory address of x is the memory address of apples. And so you're reading and writing to the same spot in RAM. Okay. So in Zybooks, you will see them format it like this, which is fine. Spacing doesn't matter. You can do that if you want to hate people that come after you. You write code like that. Nobody writes code like that. Nobody writes code like, maybe some people write code like that. But the point is that it doesn't matter where you put the ampersand. That works fine. That works fine. I don't recommend it. Zybooks does it that way. My preferred way of doing it is this. Okay. And the reason for that is a little bit subtle. Zybooks does it this way because they want to emphasize that x is an int reference. In other words, it is a memory address being sneaked in under the scenes, and so x's memory address is that of Apple. That's technically more accurate. The reason for that is if you ever define multiple variables together, like int reference x, y, and z, what do you think the type of x is? If you had to guess, what's the type of x? Just guess. You can be wrong. Like I told my previous class. Being wrong helps you learn more than being right. So every time I make a mistake in Japanese and I get corrected, I remember that a lot more than if they're like, yeah, you're mostly right, or something. So be brave, be strong, get it wrong. You're not going to reveal any dark secrets to me that you don't know how to program. This is a class for people that don't know how to program, right? Like a lot of students are like, I'm just embarrassed. Like the professor will know that I don't know how to. Yeah, I know you. Like you're not supposed to know how to program. This is a class for people that don't know how to program. And wrong. The type of x is int reference. X is a reference to an integer. Okay, which means that it holds the address technically of some other integer. And this won't compile, by the way. If you try doing this, it's going to get mad at you. You can't have a reference to another variable without actually having another variable. Okay, so but I'm making a point here. This is obscure C++. You don't need to worry about it. But I'm making a point, and the point is, what do you think the type of y is? The type of x is int reference. What do you think the type of y is? Yeah, the type of y you would think is int reference, because if you do something like this, if you say float ABC, the type of A is float, the type of B is float, the type of C is float. And if you do something like this, you would say, okay, the type of x is int reference, which it is. The type of y is int reference, which it is not. What? Yeah, it's not. That's why I don't like writing the type system this way, because it looks like the type is int reference. Nope. The type of y is int, and the type of z is int. So that's why I don't like it when people write int reference like that, because that's not actually the type. Okay. So what you would have to do if you wanted y to be a int reference is you would have to do that. And that's why I put it like this. So the ampersand is better attached to the variable than it is to the type for that reason. So this is more correct. If you did this, what we had before, it appears as if you're declaring 3 int references, and you're not. You're declaring 1 int reference and 2 ints. And that's very misleading to most students. So that's why it's more properly done on the right-hand side here. Okay. So you will see me write code like this. You will see Zybooks write code like this. Just be aware, it don't matter none. Okay? You can put whatever kind of spaces you want there. No, actually don't do that. But you can put whatever spaces in there. C++ will not care. Okay? So that's the syntax of call by reference. So, get rid of A, B, and C. All right. So the difference between call by here. Okay. Learning point for today. Learning points for today. Call by value makes a clone, i.e. copy, i.e. duplicate, i.e. doppelganger, of the value passed in, of the variable passed in. Call by reference, which is with the ampersand, passes the original variable in with no copy. That's the difference. Oops. Okay. What do you guys think? So if you do this, call by value, you get a duplicate of apples. If you do this, you get apples. And these changes here, when you say x is equal to x times 4, with this bad Oscar in here, when you say x is equal to x times 4, you're multiplying apples by 4 back in main. Okay? If you do it the normal way, then you're just you're multiplying the duplicate of apples by 4. Apples doesn't change. Okay? When would you not want to make a copy? We get the real deal, not the bootleg. It depends what you want. Do you want a copy or not? For something like this algebra thing, I want a copy. I don't want, like, I don't want this to be modifying apples. You know what I mean? Like, doesn't make sense. Like, you know, if I have a function, that is gonna, I don't know, yeah, like this, like, it wouldn't make any sense for apples to change. Like, what if I was doing like absolute value, right? Int absolute value x. If x is less than 0, return -1 times x, else return x. Right? Like, if I was doing, like, cout the absolute value of apples, you know what I mean? Like, it'd be very weird if apples, like, changed. You know what I mean? Like, it'd be very strange, right? Like, because we could do this, like, we could do this, right? So, like, if x is less than 0, multiply by -1 and return x. It'd be very, very odd if this absolute value function here modified apples. Like, if apples was -4 and you call absolute value and apples is, I'm 4 now, you're like, what? No, what? Like, that would just be really weird. Sometimes you want a copy. You know? Like, I want to just be able to mess around with this variable. It's a copy. It's not going to mess around with apples down here. Right? And then sometimes you want to modify the original. Right? Like, a classic example is if you want to uppercaseify a string. Right? So you pass in a string by reference. And you pass in hello world. And you want it to be uppercaseified. Right? So, hello world, right? So we went over this char c and s. So we went over this, I think, a couple classes ago. So for every character in the string, set that character to be the uppercase version of that character. And so this will go through the original string. It'd be very weird if this was a copy, because it wouldn't do anything useful. You guys see this? So if I have here string s is equal to hello world, and I want it to be uppercasefied, I can call uppercaseify s. cout s, and I get hello world. Okay. And the only reason why this works is because I'm passing in the original, right? If I was doing this call by value, yeah, I can go over it. If I was passing this by value, what do you think is going to happen? If I'm passing in a copy, if I'm passing in a copy of this string, am I modifying the original string out here in main, or am I just modifying the copy here? What do you think? If I did a call by value, what would this do? It's going to modify the copy, and then what happens to the copy? Yeah, I've got a copy here. The copy is uppercaseified. Then what happens to it? What do I do with this? What do I do with s at the end of the function? Absolutely nothing. So what happens to it? It goes away. So what was the point of all this? Nothing. Right? I just did all this work for absolutely no point whatsoever. Right? So, hello world is not capitalized. You have to pass something like this by reference, because that is passing in the original variable, and now the original variable is being modified by this range-based for loop. So this is, again, called a range-based for loop. And what it does is, for every character in S, it sets that character to be the uppercase version of the character. Okay. The ampersand means use the original character, the string, not a copy. Same notion, actually, as what we're learning today. So that means give me the actual character from the string, don't make a copy. Because if it was a copy, if I did that, then it will make a copy of the character, change the copy, and then the copy goes away. And it won't uppercaseify anything. So you have to change the original, and then it uppercaseifies. Okay. And so this is sometimes called a for each loop. Okay. So for each character in the string, set that character to be the uppercase version of the character. Starts at the beginning, goes to the end. It's much shorter, much more compact, faster to write, easier to read than a traditional for loop. I could do it with a traditional for loop like this. For size the I equals 0, I is less than s dot size, I plus plus. S dot at I is equal to 2 upper s dot at I. So this is the same thing. These 3 lines here is the same thing as these 2 lines here. So starting at index 0 in the string, going till the end of the string, 1 letter at a time, change the character at that point in the string to be the uppercase version of that character in the string. Same code. This is a lot more readable though. Same running time, essentially. Probably faster, maybe, if you have the optimizer turned on. So, yeah, a lot of people forget that ampersand though, and then their code doesn't work and they don't know why. So be capable of writing the longer way if you have to. If your range-based for loop doesn't work, then make sure you can always punt back into this, because a lot of people forget that ampersand. And then you're changing a copy of the string, and then the copy gets discarded and nothing happens. Can you use int instead of size t? You can, yeah. And it'll work fine. You'll just get a warning. Yeah. So, right. So, call by reference. And notice, like with a call by reference function, a lot of the times we don't return a value, right? Because we don't need to. We're modifying the parameter passed in, and so this is a very, very common design for call by reference, because the thing we pass in is also the thing that we're kind of passing back out, if you want to think of it that way, because we're modifying it in place. Whereas for something like this, when it's called by value, you typically will have a function return a value. So it's not always, not 100%, but it's kind of a common pattern you'll see. If you're modifying something in place, you don't need to return anything. Or you can, like, I don't know. Like you could return how many characters were uppercaseified, or Boolean, true on success, false on failure. Like, you can do whatever you want, but it's fairly common to see something like this. Okay, so when do you use call by value? When do you use call by reference? This is the big learning point, okay? So, do you guys understand this part so far? Like with call by value, you get a copy. This is not apples, this is a copy of apples. And with call by reference, you get do you guys conceptually understand the difference between this way of passing a variable and this way of passing a variable? This one you get a copy. This one, the OG original variable from main, is actually present here. Maybe with a different name, but this is actually modifying the variable back in main. Okay, that makes sense. And that's why it's I actually find it very useful to just show students what the address in RAM is, right? When you have a call by value, this memory address is going to be a different spot in RAM. And when you do it with range-based for loop, the address of S is S. The address of S in main is so you can see the address of S in main is that spot in RAM right there. And the address of S in the function is the same spot in RAM. So when you're reading and writing to S in the function, uppercaseify, you're reading and writing to the exact same spot in RAM that you were in main. Does that help? Does that help kind of like show you what's kind of going on when you do call by reference? Because I feel like a lot of times when it's explained, it's not explained very clearly. Like people will be like, all right, is it easier to take a train and fill it with lava and ship the lava? Oh my, what the hell is happening here? Why are you filling a train with lava? Like, Starbucks confused you last night. Yeah. It can be one of the most confusing things. But I even though like printing the memory address of something is an advanced thing, like it's helpful. Like, look, it's the same. You're writing to the same spot in RAM. Like, it's the same variable. Okay, so, and if we did this with call by value, then the S in main is different from the S in uppercaseify. We're reading and writing not to the original string. We're reading and writing to a copy. And this is bad because we don't do anything with the copy. So it gets silently discarded and wastes everybody's time. Okay, so I think this is just a really nice way of just showing what's kind of going on. And that's called the reference of operator, or the address of operator. And that's why this is called call by reference. What this means is the behind the scenes, if you look at the assembly code, rather than it duplicating, and a string can be quite long, right? A string could be the complete works of Shakespeare, which I have on the server. I've got the Declaration of Independence, right? Like from Simple Calculator, it's on the server. Strings can be quite long. And so you don't want to duplicate a string if you don't have to, right? If you've got the complete works of Shakespeare, you don't want to make a copy of it when you don't have to. It's slow, right? Wasteful. So C++ gives you that control. So after you understand call by value, call by reference, the question is, okay, which one do I use now? Right? And it's not always clear. All right, so when do I learn? When do I use call by value versus call by reference? Okay. And there's some general rules and specific rules, but I can kind of answer it like this. If you want or need a copy, which one do you use? Like, in other words, you don't like you don't want the variable, like you want to modify not the original variable. Use which one? Like, if you need to be modifying the variable, but you don't want it to be messing with the person back in main, which one do you use? Call by value. Yeah. And C++ gives you this control over it. Every time you make a function, you have to decide, do I want to make a copy of the variable back in main, or do I want the original variable from main? And you just have to use your thinking skills and follow these criteria to figure out which one you want. Sometimes you do want a copy. Like, even if you're passing in all the works of Hamlet, maybe I need to modify it or something. I'm going to fix all of Shakespeare's spelling mistakes or something. I don't know. You know what I mean? Like, sometimes, I don't know. But I'm going to fix it here, but I don't want it changed back in main. Maybe that's a thing. I don't know. It doesn't come up very often. Almost always you pass a string by reference. But if you really do want a clone of something, then call by value it is. Okay. So that's rule number one. If you need a copy, like if you really want a copy, you're going to mess with call by value. If you want to modify the original value back in main, and when I say back in main, it could be another, because main could call a function, which could call another function, which could call another function. So when I say back in main, I'm just assuming main is calling a function, but technically it could just be, it's going to modify the original value back in the calling function. It's simpler to say back in main. Okay. So if you want to modify the original value back in main, like with upper caseify, use which one? So in main, we've got a string, we want to uppercase it, we pass it to a function, and that function should modify that string so that it's all uppercase now. Should I use call by value or call by reference? Call by reference, good. Yeah, because it needs to modify my string back in main. I pass that string to uppercaseify with the intention of it messing with it and uppercasing it, right? I'm passing in the declaration of independence, and I want you to uppercase it for me. Okay. So that is most definitely call by reference. If you have a large object you're passing in and you want it to go fast, what do you think is faster? Passing in the complete works of Shakespeare or passing in the RAM address, 64 bits, the RAM address where the works of Shakespeare are at? What do you think is faster? Passing in a gigabyte of data or passing in 64 bits of data? Yeah, it's much faster to pass in 64 bits. Hey, by the way, at this RAM address, you can find the works of Hamlet. You don't have to copy it all. It's right there. And so for that, we use call by reference. So call by reference is faster with strings, and strings are the only large objects we know right now. So when we get to vectors and other things, we typically use call by reference with them. Okay. And usually for this one, we pass it in Const Reference. Okay. So like last time we talked about int count chars in string, right? So we passed in a string s, a char c, and if s is equal to like that, and C is equal to then this returns 5, right? It counts how many times a letter appears in a string. And I told you guys this is not quite right. And the reason why it wasn't quite right, let me rewrite it real fast. Count is 0 for every character in the string. If that character is the thing we're looking for, count gets incremented, return count. Okay. So if you pass in all the works of Shakespeare, rather, and you pass in capital Q, this will run through the complete works of Shakespeare, and every time it sees a Q, it will increment count by 1, and when it gets to the end, it returns the count. Okay? So I told you this is not quite right. And so why is that not quite right? What should I change string S to be? Because right now, if I'm passing in Hamlet, it's making a copy of Hamlet, right? That's call by value. Call by value makes a copy. Okay. How does the function's memory address work with the parameter's address? With pointers, yeah, behind the scenes, it's just passing in. When you do this, if you actually look at the assembly, it's like, maybe it'd make more sense with an end. Like if you looked at the assembly for this, when the function gets called, it takes the number, 4, and it puts it into register 0. Register 0 is used for the first parameter to a function. And so it takes the value 4, puts it into register 0, calls f. F reads the value 4 out of register 0, and feels like, all right, that's x. And if you read and write to register 0, that's not modifying apples. It's just register 0. It's a copy of it. If you did this with an ampersand, like that, what happens is register 0 gets a memory address. So the memory address gets passed in rather than the value. That's why it's call by value versus call by reference. A reference is a memory address. So with call by value, the value of apples is put into register 0. Register 0 is the first parameter. If you do this, what happens is it passes in the memory address. Wherever in RAM apples is living, that's put in there. And then every time you read and write to X, you're reading and writing to that memory address back home in RAM somewhere. Okay? So there's no speed benefit for doing this. It's slower, actually. It's probably slower to do it this way. So call by value is usually better for ints and chars and floats and doubles. And call by reference is usually better for strings. I'll go over that rule of thumb in just a few minutes. So coming back here, the problem is that we are, like, if we're passing in all of the works of Shakespeare and we do this is call by value. Call by value would duplicate all of the works of Shakespeare and then count the letters in it and then throw away the duplicate. It's terrible. We want this instead, right? We want that instead. You guys understand? Then we don't duplicate, a gigabyte of data or however big the works of Shakespeare is. You guys understand? It's faster. What's the danger? Could I accidentally screw up? Like back in main, I've got all the works of Shakespeare in a string. Could I accidentally screw it up? What if I did this? What would happen to the works of Shakespeare? Back in main, if I set S to be the empty string. I've gone to all this time and effort loading all of the sonnets and all of the tragedies and comedies and histories, and I pass it to this function that's just supposed to tell me how many capital A's are in the works of Shakespeare, and then the goofy programmer screws up and does this. What happens to all the works of Shakespeare back in main? Gone. Right? So there's a danger to passing by reference, because if you do something accidentally, and usually it's not this blatant, but like there are functions you can call and they might modify your thing. So there is this thing called Const Reference. And Const Reference is this. Okay? So if you put const in front of the string, now that means that string can be read from, but it cannot be written to. So it protects you. Okay? Protects you. Do you see this is a compiler error now? The compiler's like, yo, you can't write to that string anymore. And so 90% of the time when I write a function with a string or something like that, some of the time I'm modifying it, you know, like this, you know, happens. But probably 90% of the time when I pass something large to a function, I'm passing it const reference. I'm passing it reference for the speed, and I'm passing it const so I don't accidentally mess with it. Okay? So this is passing in just the memory address of the complete works of Shakespeare, 64 bits instead of a gigabyte, right? So this gives me speed, and this gives me safety. That's why we pass in const reference, 90% of the time. Okay. It's just like, if you're working on Photoshop and you've got a variable that holds 500 megs of image data, you don't want to ever pass that call by value. You know what I mean? Like if you've got some variable and you don't know how to make those yet, but you can make a variable that's 500 megabytes in size, and you pass it to a function. You don't want that function to like make a copy. like you're gonna be sitting there like forever. Like, all right, it was supposed to print out the first color in it. Why is it taking 5 minutes for me to find one? It's because it's copying the whole thing for you. You know. So anytime you have any large bit of data, you pretty much always pass it by reference. And then the question is, do I want to be able to modify it? In this one, no. It would be really weird if I asked, if I counted how many Q's were in Hamlet and then it destroyed Hamlet. That'd be really weird. So in a case like that, we pass it by const reference. And if we do want to modify it, then we just pass it by reference. And that's the big thing for today. Okay. So there's kind of three situations. Okay. You need a copy, call by value. You want to modify the original, call by reference. And if you're passing something big, it's always going to be called by reference, almost always. But you have to decide, am I going to be modifying it or not? And if you're not, you pass it in as const reference. So this is the way that we pass in almost every string, unless we're deliberately modifying it. Okay, so there's a programming language called Java, and the Java language enforces these rules, but it's good advice for C++ developers to mimic it. Okay, what are the rules? All primitives are passed by value. Okay, so int, float, double, char, bool, they're all called by value. They're passed like this. Okay, you basically very rarely pass in something by reference, but that's like if you want to write to it or something, I can make a function like void increment like that. I guess I could do, and then for main I could be like int bob equals 5 and increment bob. Like if this was in main, this would be fine, I guess, if that's your thing. Like you can do it. Like this is just a rule of thumb, right? You don't have to do this, but it's a good rule of thumb. Okay, it's a good starting place. So basically, if you ever have a function that takes an int, just pass it as call by value by default, unless you need to otherwise. All large objects, strings, Photoshop, images, whatever, call by reference. if you don't want the large object modified by the function const reference. That's the rule. That's the rule of thumb. It's not an art. It's like the pirate's code. It's more of a guideline than a rule, you know. But it's a good place to start. Okay. So you will write code where you're passing an int by reference. Like that'll happen. Like it's not the end of the world, but just as a good starting place. The code is more what you'd call guidelines than actual rules. Yeah, exactly. So the Java language itself enforces this, but in C++, you choose. You choose. Is this parameter called by value, or is it called by reference? And it leaves it up to you. It gives you that control. And it's annoying to us. Like Bell in the earlier class was saying he misses that when he doesn't do C++ development because he misses being able to choose, do I get a copy or do I get the original variable? But this is a good place to start. So anytime, like if I was going to make a function that took a float, a string, and an int, I don't know, int Bob, it would be like float f, string, usually it's going to be a const string, ampersand s, int x, right? You guys see that? So if I'm going to be taking 3 parameters, one of which is a float, one of which is an int, one of which is a string, all the primitives by default, before I, like I said, it's not hard and fast, but by default I would write it this way. You guys with me on this? All the primitives get passed in by value. All the large objects, potentially large objects, a string could be small, but it could be very large. All the large objects get passed in by reference. All the primitives get passed in by value. And then the only question is, do I want S to be modifiable or not? And usually it's not. So, do you guys understand this rule? Do you understand why this rule of thumb exists? Okay. So yeah, if you stick to that rule of thumb, that'll cover you 90% of the time. All right, so let's write a function that will like modify a string. Okay. So we've already got one here that does like uppercase phi. So let's do one that will. Let's see. In the last class, I made a function that just added a happy face to the end of a string. So let's do that one. Let's call this like void make happy. And do I want it to be const reference, or do I want it to be reference? So what I want to do is this. Just basically at the end of the string, I just want to slap on, some, winky face. There we go. Okay. Do I want this to be, I'm modifying the string. So we're going to pass in the declaration of independence. At the end of the declaration of independence, we're going to go, right? This is modifying the string. Can I do this with const reference or not? No. If I'm actually modifying it, it can't be const. Const means read only. I can't modify it. So we'll just drop that out, and we got a perfectly good function now. Okay? So, string declaration of independence equals there. So the declaration of independence, we paste it in like that. And so we're going to start off by scouting the declaration of independence, followed by a couple new lines, space it out. Then we're going to call make happy, because we don't want King George to get too mad at us, right? So we're going to give him a little winky face afterwards. Maybe a winky face is going to undermine us. Let's not do a winky face. He won't take us seriously for a winky face. We're going to blow him a kiss. There we go. So, yeah. You can't declare war on rebels that use the kiss emoji, right? You can't do it. It's not psychologically possible. If somebody's blowing you a kiss, like, you can't be like die. Like, it just doesn't work that way. So we're gonna soften it up a little bit. So we're gonna make the declaration of independence happy, and then we will print it out again. Passive aggressive, bad breakup. Okay, so we run it, and so we got here, we hold these truths to be self-evident, element are created equal, da 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 da. And then down here, we have the exact same string, except right at the very end, we're like, bye-bye, Georgie. Ah. And there you go. So, yeah, changes the mood of the Declaration of Independence. Right? So, mwah, bye, bye-bye, bye, gonna miss you. Okay. So, do you guys see that? So if we're going to be laughs in colonial, laughs in British. So if you want to modify a string, you got to pass it in by reference. That's just, that's this here. If you want to modify it, then call by reference is your beast. If I did this by value, then it's going to be pointless, right? Because it takes in the Declaration of Independence, adds a below you kiss face to it, and then it discards the duplicate, and so you can see that nothing changed over here. So this function is literally useless. Literally useless if it's called by value. It's got to be called by reference. And then some people might try to make it const reference, but not. We're modifying it. If you're modifying it, it's just going to be reference. Okay. For something like this, where you're just counting how many letters Q or whatever appear in the thing, yeah, of course it should be const. It would be really weird if the Declaration of Independence changed just because you counted the number of letters in it. So let's, in fact, do that. Let's see out count, what is it? Count chars in string, taking a string DOI, and we're going to count how many times the letter E appears in it. And so 176 lowercase e's. There you go. 176 lowercase e's. Now, we want to count uppercase e's too, so rather than doing it twice, I think we should just uppercaseify it, right? So we're going to make it happy, and then we're going to uppercaseify it like that. So we're going to be shouting at King George now, you know what I mean? Like, we're shouting at King George. We hold these truths to be self-evident, that all men are created equal. They're endowed by their creator, certain inalienable rights, blah, 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 blah. So it's like super aggressive now towards King George. So like, the blowy kiss face might not be enough. It might not be enough. We might have to soften it a little bit more. So, what do you guys think? Rocket ship? Diamond hands? What do you think? One more kissy face? Yeah, okay, fine. There we go. So now we're shouting at King George, but at the end we're blowing him 2 kisses, and we're going to say to the moon, diamond hands. If he trades in Dogecoin and all, he'll be fine with us. He'll let us go. That's just how it is. That's how it works. Now you might notice we don't have any lowercase e's anymore because we uppercased them all. So, anymore. So let's count the number of capital E's, capital E, like that. And you can see, it's still 176. So we didn't have any capital E's, I guess, in the first one. Okay. So we've got 176 E's. But you notice how, for the counting, like to count how many characters there are in the string, that one's being passed in by const, because it would be really strange. It wouldn't make sense for the string to change. So we pass it in by const reference. Whereas if you're going to be modifying the string, you pass it in by reference. So these are the 3 rules. Okay? Those are the 3 rules. Yeah. And in general, if you have a primitive, in general you pass it in by value. And if you have a string, in general you pass it in by reference. So in general, primitives are passed by value. big objects by reference. That's kind of rule of thumb. Okay. Primitives and int float. 176 E's, and the year was 1776. I think you're onto something. I think Thomas Jefferson was trying to leave us a secret code. And if we can decipher the code, it'll lead to a secret vault beneath the Jefferson Memorial, which will find the original Declaration of Independence. National treasure. Right. Okay. So, you just need to call up Nick Cage and let him know. Let him know about this. All right. Or what was the other one? The Da Vinci Code, right? Like that nonsense. Okay. They're making a third national treasure. I mean, Nick Cage probably needs the money, you know. He's pretty bad with money. All right, so that's basically what I want you to know. Okay. I want you to understand the difference between rule of I want you to know the difference between call by value, call by reference, and when you should use them. Okay. If you can do that, then you're good. This is oftentimes the hardest thing for students to learn, but I don't know. I think if you just explain it right, it's not too bad. Okay. This will start you off pretty good. Yeah. It's an int, call by value. It's a string, call by reference. And you just need to figure out if it's const reference or not, depending on if you want to modify it. You understood this more than nested for loops? Good. Good. Awesome. Good to hear. So your homework, it is now lab time. You have until 4. You are free to work on your mastermind assignment called Hack the Mainframe. And I will hang out and answer questions. And Mincarelli and Corrente are here as well. Let's see if any other experienced students are here. Nope, just the two of them right now. And me, of course. So, yeah. Just post your questions. And or if you just want to leave and take an early vacation, I'm not going to stop you. This is college, not prison. Not high school. But I repeat myself. Okay, sounds good, you guys. I'm going to sign off now. If there's anything else that needs to be said, I guess I can turn the recording back on. So I'm just going to pause the recording, but that's probably it for today.